Thank you. So today we'll be talking about where does your Ansible code come from. So basically, we are going to talk about supply chain security. So first of all, we will introduce the concept of an automation supply chain and why it's important to care about it and its security. The second point that we'll be talking about will be about how to actually secure your supply chain, which tools can help you to do this, and then some conclusions that we'll wrap up with. So a little bit about me. I've been working for the last 20-ish years. The majority of those years I've spent them doing consulting and operational kind of work. I have started to work with Ansible in 2013, which was very early into the Ansible story. I think at the time Ansible had 1 or 2 years. We were at roughly version 1.0. So it was fairly early on. I've also written some books about Ansible, and at the moment I do work for Red Hat, which is now the owner of Ansible. It was not back then in 2013. So some disclaimers about this talk. First of all, this presentation wants only to be a primer, not a full course. Obviously, the full course would be days long. Security is a very complex topic and a very nuanced topic as well. So the idea here is to understand the scope, as well as some tools that can help you, but not the exact implementation and configuration for every single one of those tools. Second point is that everything we are going to discuss today is open source. So obviously, you can also buy versions of those things or flavors of those things from various vendors. But everything we are going to discuss today is open source. Third point is that in the slides, there will be many links. But the good part is that at the very end slide, there is a link for this slide deck. So effectively, you will be able then to get it and then click all the links throughout the presentation. So let's start from supply chain attacks. What are they? They are defined as malicious activities, obviously, because they are attacks, that targets the sourcing, development, distribution, and deployment of code. So as you can see from this definition, we are not talking about a malicious activity against one specific point, but more in the chain, in the movement of code from one step to the following step. So this is a very critical aspect of supply chain security, and this is going to be the focus of today's talk. Why should we care about this at all? First of all, supply chain attacks have devastating impacts on organizations. And this has multiple reasons for which those kind of attacks are usually more devastating than other kind of attacks. The first reason is that they are very difficult to detect. So while if you have like an attack on your Apache server, for instance, you can have some metrics that start to, to be weird at least. So you can easily detect that something is going on. Maybe you're not detecting exactly what is going on, but at least that something is going on. For supply chain attacks, usually it's very, very hard to actually detect that there is something wrong. And for this reason, and also for the fact that a lot of times supply chain attacks do involve very complex systems or chains of systems, they are fairly hard to defend against. And another aspect is that a lot of times, since those supply chains tend to be long and shared between different companies or departments, even you can be attacked or you can be subject of a supply chain attack, even if you were not the intended target, but simply because you are sharing that part of the supply chain with a different actor, which was the intended target. And lately, they are becoming very common. We have seen, I would say in the last 5 years, at least 5 to 10 huge ones. And then obviously there have been a huge amount of smaller ones that we are not aware of, or that maybe even the targets are not yet aware of. So I think there are many reasons why they are becoming more common. One of which is that supply chains are becoming longer. So becoming longer, they are also more prone to attacks. Another aspect is that this has not been the focus for the security field for many years. So effectively, those are weaker, so easier to attack than other kind of scenarios. So why should we care about this? So we as automation people, automation experts, why should we care about this in the context of automation? The first reason is that automation code, and Ansible code to be more specifically, usually runs with very privileged accounts. If you want to have Ansible deploying your Kubernetes, Ansible will need to have that level of access to actually deploy your Kubernetes. And therefore, it's always going to be able to, attack or tweak your Kubernetes installation. Second aspect is that usually, up to today, I would say, supply chain security for Ansible code has not really been a thing. So effectively, those chains tend to be not as secure as they should be. So if we move to the automation supply chain more specifically, let's see a little bit how it usually works. Because there is this strong conception that there are supply chains and they are insecure because they have always been insecure and now it's a problem, or we might see this as a problem. But the reality is that the problem became a problem over time. It did not start as a problem. So usually, the Ansible automation starts within a company like this. You have a developer on their own machines. They write Ansible code, and then they run it from their machine with their own access account, and they configure some nodes. Sometimes their manager don't know this, that they are using Ansible. They just know that that person installed that software, and that's great because, that was his job. Other times, maybe their manager knows, but does not really care too much, or maybe knows and cares, but that's okay. The developer is running the application from their own node, and they are managing the nodes directly. So there is just an SSH connection between the developer machine and the target host. Now, it can be something different from SSH. If it's, for instance, a Windows target, then it would be a WinRM or any other kind of protocol. But still, a lot of times, or hopefully every time, this connection is encrypted. So, the scope of security and supply chain here is very limited. We only have one link, basically, and should be secure by default. Now, the reality, though, is that once that developer proves that this method actually works and works better than what they used to do, their team usually start to adopt it. So what you have is slightly more complex situation where we have multiple developers, maybe people within the same team. They commit something to Git or any other kind of way of sharing code, and then the usual developer of the previous slide then still runs Ansible playbook on their machine and configure the nodes. Now, as you can see, this case has a little bit more complexity, but still, we do have a human there, that blue developer, that still should at least check that they are what they are running, and that they are running something that is legitimate. Now, usually that's not the case, but from an organizational point of view, it does not matter, because that human is running commands, and therefore that human is responsible for the commands that they are running. So the only issue, though, is that that person sometimes wants to go on holiday. So what do you do when that person goes to holiday? Well, very easy. You pick another person and authorize them to also run the commands. So they have a privileged account, they can run the code, and everything works. Until, obviously, there is too much work, or those people are both on holiday at the same time, and then, it's obvious that this model does not scale too much. So usually companies goes to this process where basically they substitute the humans with a controller. Now, there are a couple of controllers available for Ansible. One is AWX, one is Ansible Automation Controller. They are basically the same code. They only differ because one is self-support and the other one is supported by Red Hat, but the code is exactly the same. So everything we are going to discuss works for both of them. Now, no matter which controller they choose, they put a controller. Now the controller pulls Git, and then it runs the code, and you manage the nodes. Okay. But then there is a little bit of investigation while doing this, and they discovered that actually this is not the reality in their organization, because in reality, some of the developers are actually using collections, which is great. Collections are a great way of reusing code that someone has wrote, but you need to be aware of this. Because if you are not aware of this, obviously you cannot secure that part of the chain or control it at all. So there are people, usually outside your organization, that somewhere in the world, they write code, and then your organization runs it with basically root access. Okay, might be interesting to see exactly, those people, where they come from, what is their background, do they have any security check that they are doing? Do we have, as an organization, any security check on the code that they are writing and we are executing? Hopefully. So usually what happens is that the organization says, well, let's put an automation hub here, same thing as the controller. There are a couple. Galaxy NG is the self-support one. Private automation hub, the Red Hat supported one, but same code, so does not really matter. So we do have the same people and collections, someone that checks them, hopefully, with enough time and focus to ensure that that code that we are going to execute as a root on our system does only what we think it should be doing. And yeah, everything kind of works. Now, reality is a little bit more complex than this. So effectively, we might want to also have a little bit of CI, because this can allow us to do some tests on our code or our developer code. And it does make sense to have some validation there. Now, at the beginning, usually it's like, oh, we have run Ansible lint on the code, and it passed it, so it's fine. Hopefully, over time, the tests become a little bit more, full and complete. But still, it does work. Now, there is one aspect, which is that controllers are able to, or will run your Ansible code within execution environments, which basically are Docker containers. So it makes sense to also manage them, because otherwise we are just pulling them from somewhere, either from the Ansible community, from Red Hat, from any other provider that would provide one for you. So maybe it's not exactly what we want to have. We want to manage them locally as well. So we can also build our own as well, and we can push them into the automation hub. The automation hub is able to both replicate containers that comes from outside your organization, or that come from your organization with, by building them. And also, you can, if you import execution environments from outside, you can also police them, authorize them exactly as you would for collections. So how can we actually secure this? Because as we have seen, this supply chain became fairly long. It started as a single developer writing and executing stuff from their own machine to, well, a situation that has a lot of steps and connections in between systems. So there are many ways of doing this. I think that the first important aspect is to arrive to this picture, well, not this picture, but the picture within your organization that represents your flow, because once you arrive to a full picture of your flow and how it flows, how your code flows throughout your organization, then you can start to analyze it, secure it, improve it, or whatever you want to do. So first of all, very important to actually map it. Second aspect is make some decisions on what is important for you, for your organization, and what is not. Sometimes you have infinite money, so you can secure everything at the same time. That's awesome, but that's usually not the reality. So in reality, usually you want to start from something that is easy, that will give you the biggest results. And then over time, you can focus on more specific details or smaller details that will give you, smaller benefits. But one of the aspects here is, what do we want to ensure? I think we want to ensure a couple of things. First of all, that only the code that is written by those developers and that is validated by these people and is that are created by this person actually gets executed. That's a very basic thing. Another thing that I think we should ensure against is that developers should not be able to push to the controller. So they must go through the CI. The reason is that if in the CI we have some kind of validation, then we really want to have that validation to be executed at every commit. So an example of a CI that is very important to be executed is if our CI checks, for instance, that change already happened in lower environments. So if we are pushing to prod, that CI might be checking if the same change also already happened in test, for instance. So we really want to ensure that first, those people code is the one that is executed there, and the other part is that all code before going to the controller pass through the CI. Okay? So how do we do this? First of all, we know that there is Git here, and those people write Git code, or they commit code into Git. So Git is a very good tool, is already there. Why not to use it a little bit more? So let's sign Git commits. Signing Git commits is fairly easy. You just add a -s, capitalized S, to your commit command, and you are signing it. And there is, the documentation on how to do this exactly. Now, reality is slightly more complex because this works only if you already set your client to know exactly which certificate to use. So you need to first have certificates or keys, whatever you want to use, and those needs to be, shared or moved to people's machine. You need to decide who gets to create those certificates, where those certificates are stored, how they are stored, and how they are secured, and how they are trusted. So there are a bunch of decisions there. But from a user perspective, it's really just one additional flag. And also, you can set the client in a way that it automatically adds the signature at every commit. You don't have to specify it. So it's very trivial for our developer to actually do this. And then we can validate those Git commits in a very simple way, which is git verify commit, and then commit ID. So there is also very good documentation on this, very simple. Now, there is one aspect here, which is git verify commit only verifies that a commit has been signed by a key and the ID of the key. It will not say, oh, this person, this key is authorized, this key is not. So you will need to develop some kind of logic in your code to actually decide that some keys are authorized to push code into your repo and others are not. Which means that you will need to think more about how to ensure that level of trust between the various keys that can sign your code. So effectively your developer keys. Now, if we go back to the image, what we can do is to have the commit that are signed by our developer, and then the validation in the CI. The reason for this is that in this way, we ensure that this part is secure, so no one has modified our code in between, but also that the code lands to the CI and not directly to the controller, because if it would be landing directly from the controller, that would mean that we would be trusting those developers' keys to be run on the controller, which means that they could potentially skip the CI. So if we check it in the CI, then we are sure that they are not skipping the CI. So what about the next step? What we can do is sign the projects. You can sign them with GPG keys. There are also other ways, but GPG keys are probably the easiest one. And you simply run Ansible -sign project GPG sign, and then the folder, which could be dot if it's the local folder. And yeah, in this way, you create a GPG signature of that project, of that folder, and then you can distribute it and validate it. And how can we validate this? First way is manually. We are probably not going to do this in production, but still, it's useful to know. Same tool also verifies signatures in a very similar way as the Git was doing. Also, we can do it throughout from the controller itself. This is the documentation for the controller part, and it's very straightforward. Simply, we will need to flag a field into the Ansible controller or AWX, and it will validate the signatures. Now, you can also specify which keys should be authorized there, and at that point, you can create that level of trust. So in this way, if we sign it in the CI step and we control it in the control step, then we have also secured that chain, that link of the chain. So as you can start to see, it's not like we have one way of securing the whole chain in a single step. Also, we don't want that. But even if we would like to, very often we would be securing the various steps in different ways, or maybe in the same way, but with different encryption, decryption, or signature validation, so that we can ensure that everything goes throughout the steps. And this is a very simple case. Maybe you have a more complex situation where you have commit, git, CI, environment, CI, environment, CI, environment, CI, environment, and then other stuff. And then at that point, you might want to have even more steps where you sign and validate, because only when you sign and validate with different keys, you can ensure that the code went through that path and did not skip, from one step to the other. So at this point, our code, the one that our developer wrote, is, I would say, fairly secure, and we can be confident that the code they wrote is exactly the one that we are executing in our controller, and that the code went through the CI. Perfect. Now, what about all the rest? Because we have a lot of other code here. So first step is, let's look at collections. We have collections here. Collections will be arriving here and will be used by the controller, but also when you create execution environments, you can embed collections. So it's also important to validate those collections when you are building your execution environment. So how to sign them? Multiple ways. You can do it manually. So with the GPG command, you can manually sign a collection. You simply sign the manifest, basically, and create that signature of the manifest, and everything works. Or you can do it manually via the UI. So when you do the upload on the UI, you can enable the signatures, and therefore the signature happens at that point. Or also you can do it with the approval stage. So if you have set up your Galaxy NG or private automation hub so that collections are not immediately imported or immediately uploaded and available, but they have to be approved by someone, you can set it up so that basically in that approval step, the signature gets posted. So in this way, you can also be sure that not only someone validated it, but someone also approved it. And also, a nice thing that you can do is import this from something that from a repository that you are downloading it from, basically. So you can configure collection synchronization so that basically when upstream, whatever upstream is for your collection, uploads a new version of it, your repository fetches a copy. And then in the process, they can also fetch a copy of the signatures. So obviously, this is just proving that upstream has signed it, and hopefully it's a valid signature. So it's not that you have approved it, but maybe your upstream is someone you really trust. Let's say that you are using Cisco hardware, and you really trust Cisco because, well, if you have everything Cisco and you don't trust Cisco, you have a problem. So maybe you want to trust directly that Cisco developers know what they are doing, and therefore you trust their key and their signatures, therefore. And obviously, you have more documentation on exactly how to implement this in the various cases. Now, speaking about validation, we do have multiple ways, and we will need to use multiple ways to validate this. First of all, you can do it manually via ansible.galaxy, ansible-galaxy collection verify, and it will verify this. This is very useful for your PC or on your machine, but not very useful in the bigger schema of a production pipeline. So we can use Ansible build when we are creating execution environments. So with Ansible build, you do create execution environments, and you can specify the --galaxy-keyring equal, and then a keyring, and then it will validate that all collection have been signed by one of the keys within that keyring. Or you can also do it in AWS/Ansible Automation Controller, where it can check that all collection that gets imported are actually signed. Now, if they are coming from an execution environment, that is not really something AWS would validate, because it's assumed that you have already built an execution environment that, and in that build phase, you have validated all the signatures. And then obviously, usual documentation for how to implement this exactly. So in this way, we can secure a couple of things. One is the collection to automation hub. One is the automation hub to execution environment. One is the automation hub to controller for the collection themselves. Okay. So what do we still need to validate? The execution environment themselves. So if we created the execution environment, obviously we have checked the collection that we have built in, but how to validate that execution environment is exactly the one that we are running in production with, obviously, e-signatures. So how to put them? There are multiple ways. You can do it manually with Scopio. Scopio is one of the tools within the Podman utility. Basically, when you can simply do Scopio standalone sign and then manifest and there are various other parameters, and it will sign your image. Or via Podman itself, with Podman push, and then sign by and do it that way. You can also do it with Docker. So if you are using Docker, you can also do that. Or you can do it manually via the UI of Galaxy NG or Private Automation Hub, because usually you would upload your execution environments into your automation hub, and from there you can also send them manually or automatically when images are pushed. So effectively, if you trust the builder of the image, every time someone pushes an image, the image gets signed in this way. Is this the best option? Maybe. It depends on your situation, your risks. Also, you are trusting probably a little bit more here than in other cases, so you need to choose if that's the right decision for you. And the usual links on how to exactly do this. And what about validation? First of all, we need to understand that those images are Docker/Podman images, so they are container images, and both Docker and Podman have container policies. So those are like JSON files that you can drop into the execution node, so whatever node will execute that container, and you can specify in that JSON file that all images that can be executed by that node needs to be signed by certain keys. And this is not only true for Ansible nodes, this is in general true for every Docker/Podman environment. And we can leverage this to have that signature validation on the controller nodes or the execution nodes, if you have different nodes for controller and execution nodes. And specific details are there, but it's a fairly used pattern also outside the Ansible space. So in this way, we can ensure that this link is secure if we have signed it here and then upload it there, and then also we can check the other one. So as you can see, we have linked, we have secured all the various links here, and in this scenario now we have a way more secure environment. Now, this does not mean that this environment is secure, because there is no such thing as a secure environment, but is way more secure. Now, the real question is secure enough for your use? But that really depends on exactly what you are doing and a lot of other things that are outside this image. So just to give you an example, all of this works if the nodes that are signing the code actually are trustable. So do you trust your CI? Do you trust your automation hub? Those are critical points, because if your CI is compromised itself, this means that it can validate those people's commits and then sign it, or it can start to sign code that arrives from third parties. So you need to be sure that your CI is actually secure. Same thing for the automation hub. If your automation hub is putting signals to somewhere, then are you sure that that automation hub is actually secure? Or, what? Because if it's compromised, obviously the whole security model breaks. So supply chain security is not something in substitution of any other kind of security. It's just an addition to the usual security practice that you should have already in your organization, and you should evaluate also in light of those potential weak points for supply chain security as well. So some conclusions. First of all, automation can be a very interesting target for attackers due to the high level, high privilege that it comes with. Second aspect is that automation supply chains tend to be long and complex, and a lot of times not very well known. It is critical to map your automation chain and to keep that image up to date, because maybe it was what you are mapping today is true today, but might not be true in 1 year time. So you need to ensure that every so often you check that your reality and your map actually map, and that you don't have any additional risks or any risks that changed throughout the time. And there are many tools to supply your supply chain. There are no single tool that can fix all the issues, but there are many tools that you can use and configure to do exactly what you want. And also those tools tend to be very flexible, as we have seen. So you can choose which parts of the supply chain need to be secured together and where you want to put choke points of your security, so that effectively you can be sure that every path goes through those points. So with this, I leave you with some links. The first one is the slides that I presented today, so that you can easily find them and click all the links. All the links are clickable from the slides, and then some contacts of mine. Thank you.